everyone. We're going to run through a series of 3 lessons for today's Webex lesson. Broken up in 3 parts, so it'll be 3 separate videos. So let's go ahead and get started. First one we're going to do is we're going to do area of the triangle. Now this is pretty much geometry. Not a huge pre-cal topic, but more of geometry. So let's go ahead and get that. And this is for geometry and pre-cal, all 3 of these. Now my geometry students aren't getting this year, but perhaps next year. Alrighty, so what we're going to do is we're going to find the area of the triangle using side angle side. Now if you remember, the triangle is 1/2 base times height is equal to the area, alright? And what we're going to do is, if it's side angle side, we're going to have a side, an included angle, and a side, and we just simply plug it into our formula, which I'm about to show you how to get that. And what I have here is, if I have 1/2 area of the base on height, my base is 150, so I have 1/2 times 150. All we really need is the height. But using trig, we can find that, because here's my height right here. This is opposite over hypotenuse, that's sine. So h is equal to sine of 40. Well, actually, we'll get to what h is equal to h over 100, right? So opposite over hypotenuse. We're going to multiply by 100 on both sides. So h is equal to sine 100 sine of 40. I'm going to take that and plug it in right here. So that's just 100 times sine of 40. Put that in the calculator and you have the area of the triangle. So I just showed you how to derive it, but I want to do it one more time. And it's called the side angle side formula for a reason, because we have an angle and we're going to work with this side and this side. Now this is your regular oblique triangle here, and we need to have the height from it's basically your altitude from a vertex to the opposite side that's perpendicular. So if we do this, we have sine is equal to h over b. Sine of angle A is equal to h over b. Okay, and when we multiply this, we have, that's an h, we have b sine A is equal to h. And again, 1/2 base times height. Well, this is nothing more than this is nothing more than side C. So we have area is equal to 1/2 side of C, this side, times because that's my base, times my height, which is b sine of A. Now I typically write it like this: 1/2 AB sine of C. Okay, and what this is my formula is my 2 adjacent sides and my included angle, side angle side. So these are the 2 sides, doesn't matter which order you put them in, and that's my angle. So that's how we're going to find it. So here I have an angle with 2 adjacent sides, so I have side angle side, and that's nothing more than 1/2 times 29, doesn't matter which one you put first, times 33 times sine of 55, and that gives me my answer of something. Let me toss this in the calculator real quick. Where is my calculator? Oh, it's going to be 0.5 times 29 times 33. I typed in 66 times. Problem is, I'm blind as a bat without my glasses. 391.96, as long as I typed everything in right. 391.96. All right, and that's going to be centimeters squared. So when you have this, you don't even have to draw a picture here, because typically custom dictates if this is angle A, little opposite is little a. So this is B, this is little b, and this is angle C, so this is side C. So the numbers are opposite. If you have a big A here, you're going to have a little a over here. So you know you have this. So it's just going to be 1/2 4 times 6 times sine of 120. Hey, sine of 120 straight off the unit circle. That's just going to be root 3 over 2, right? Off the unit circle. So that's 2. That cancels out, so it's going to be 6 root 3, which I put in the calculator down here. which comes out to be 10.39. That's it. These are actually very easy. And again, we mainly do this in geometry, not too much in Precal. But I'd like for my Precal students to know these. They pop up in your later classes. Another one that we do in geometry is Herons Formula. This is actually, I teach this in quadrilaterals because we do some interesting things in quadrilaterals, and it's kind of goes in hand with Brahmagupta's formula for finding the area of a cyclic quadrilateral. Won't get into the derivation of this because this actually is kind of a complicated derivation. Again, it has to deal with circles and a few other things. So all this is just the area is equal to the square root of your semi-perimeter, which your semi-perimeter is the three sides of your triangle, all right, A, B, and C, all added together and divided by 2. And then you just put this right in. And that's exactly what we're going to do. We're going to find the semi-perimeter is equal to 5 plus 7 plus 10, all over 2. So that's 15, 22, so that's going to be 11. So when you do this, area is equal to 11 times 11 minus 5, which is 6, 11 minus 7, which is 4, and 11 minus 10, which is 1. You toss that into the calculator, which I did right over here, and you're going to get 2 root 66, which is 16.25 units squared. So Herons is actually pretty easy, and again, it's something we do in geometry, not too much in Precal. Alrighty, so moving on. But your later math join Precal, algebra, geometry, it all combines into that. So you will use this again in the future. Alrighty, so I'm going to actually post that and then get on to part 2.